Our lesson for today will be on factoring sum and difference of cubes. This will be page 54 in your notebook. It is Student Journal, page 93. The definitions that I'd like for you to write down are written. First definition, factored completely. A polynomial written as a product of unfactorable polynomials with integer coefficients. So we're going to learn how to factor things completely, but today's lesson is only on factoring sum and difference of cubes. But please go ahead and write these definitions. The second definition, factoring by grouping, we've discussed this before. Grouping pairs of terms that have a common monomial factor and rewriting as a product by taking out the common polynomial left. And you'll recognize what that is, of course, when we do it, and hopefully you recognize it by the name. I deleted the word quadratic form here. I just want you to remember this definition. So write what I highlight. Remember, all trinomials can be factored. Oh, and that says favored. Whoops, typo. That should say factored. Remember, all trinomials can be factored if written in the proper form. Whoops, let me go back to the highlighter. Written in the proper form. Also, when factoring difference of squares, if an exponent is even, it is a perfect square. That's another thing I want you to remember. Okay, looking at these special factoring patterns, you have a sum of cubes and a difference of cubes. There's something that I want you to notice about each of those. I want you to look at this sign and this sign. Compare them. Those two signs are the same. Then I want you to compare this sign with this sign. Compare this sign with this sign. What would you say when you compare the first sign to the second sign in each of those? Hopefully the word that comes to your mind is they are opposites. And then when you look at this last sign, for both of these, the sign is a plus sign. So that last sign is always a plus sign. So when we get to go back to school, you'll hear me say, don't forget to use SOAP when factoring sum and difference of cubes. If you'll notice, I want you to look. I'm not even looking at the way they factored yet, but I want you to look at the signs over here. This sign and this sign are the same. This sign and this sign are opposites. And this sign is a plus. And let's look at that second example. Okay, let's look. This sign and this sign are the same. Then this sign and this sign are opposites. And this last sign is a plus sign. And that's true every time. Now, to get the numbers that go here and here, they show that you cube them, but I always say take the cube root of your first term. The cube root of 64x cubed is 4x. And then you take the cube root of your second term. The cube root of 1 is 1. Then this gets a little tricky, but it's okay. This is what I say next. You are going to take this term. Did I change it? No. You're going to take this first term and you're going to square it and put it here. So you square this first term. Then you take your last term, you square it and put it here. And then your middle term, let me see if I can find another color. I've used the same color so many times. Here's gray. Your middle term, this term right here, ignoring your sign because we already know it's a subtraction, this term comes from multiplying these two. So let me explain that down here at the bottom also. Let me go back to green. This term that goes here is found by taking the cube root of 27x cubed, and that's 3x. This term is found by taking the cube root of 8, and that is 2. Then for the next one, this term is found by squaring both of these, square 3 and square x, 9x squared. The last term is found by squaring this term. 2 squared is 4. The middle term is found by ignoring this sign here, multiply these two. 3x times 2 is 6x. On the next page, I have several examples that we're going to do. It says we're going to do at least 6. I can't remember if I put 6 or not, but we'll see. Okay, so over here on the right, I have written down a list of perfect cubes. You may want to write these down in your notes. You can also find them by taking the cube root with your calculator, but I just wrote them down just so that we would have a list there on the side. Okay, I'm going to jump in and start with example number 1. Y cubed plus 216. First thing you want to do is to make sure that each of your terms of your polynomial are in your list over there. Of course, it doesn't have to be y cubed. It could be x cubed, any variable to raise to the third power. And then 216 is over there too. So I do have both of those in my list. Now, the first thing I would do, this is what I recommend, the first thing that I would do is I would write down my signs of my binomial and trinomial that I'm going to write. So to factor y cubed plus 216, I'm going to have an empty binomial and an empty trinomial. Then I'm going to use SOAP. This sign in my binomial and the first sign in my binomial are the same. Then, oh, that's a little bit big. Let's get rid of that. Okay, let me make it a little smaller. Okay, then the first sign in my, oops, move that around. The first sign in my trinomial is the opposite of the first sign in my binomial. So, oops, I'm highlighting. Sorry, it's been a long time since I've used this app to do this. So it's a minus. First sign, it's the same. Second sign is opposite from this sign. And then the last sign is always plus. Now, to find what goes in each term, I will take the cube root first of y cubed. The cube root of y cubed is y. I'll take the cube root of 216. And over here on the right, 216 is 6 cubed. So the cube root of 216 is 6. Then what I will do is to find what goes here, I square this. So if I square y, that would be y squared. Then I go to my last term. To find what goes in this last spot, I square this term. So 6 squared is 36 will go here. I sure didn't leave myself much room to write that, 36. And then in the middle, don't forget to find this middle term. You multiply these two, you ignore this sign, you multiply these two. Y times 6 is 6y. That's what you put there. And that's how you factor y cubed plus 216. This is the answer. Okay, let's do the next one, number 2. I didn't mention, but I need to mention the fact that if I have a greatest common factor, I need to take out that greatest common factor. When I look at number 2, I do have a common factor of 2, I believe. 16k cubed divided by 2 is 8k cubed. 54 divided by 2 is 27. Then the next thing you should do is make sure that these and these are in your list over here. I'm going to erase what I have highlighted over here. Okay. So as I look I do see this and this in the list. I see 8, I see 27, and I see a variable to the third power. Okay, so the next thing I'm going to do then is bring down my 2. I am going to take the cube root of 8 cubed. I'm not going to do that yet, sorry. I'm going to put empty binomial, empty trinomial, and use SOAP. Remember, this sign and this sign are the same, so a subtraction sign will go here. Then this sign here and this sign here are opposites, so I'll put a plus sign, and then the last sign is always plus. Now I'll do the cube root. The cube root of 8k cubed is 2k. That goes in the first spot of binomial. The cube root goes in the first spot of the binomial. Then the cube root of 27 is 3. Then remember, to find what goes here, you square this. So that would be 4k squared. To find out what goes here, you square this. That would be 9. And then to find out what goes here, you multiply these two, ignoring this sign. So 2k times 3 is 6k. And that is my answer for that one. Okay, the next couple examples I have ready for me to get started. First thing I want to do is look at my signs. Remember, this sign and this sign are the same. This sign and this sign are opposite. Last sign's always plus. Same thing with this one. This sign and this sign are the same. This sign and this sign are opposites, and the last sign's always plus. So don't forget to use SOAP when you're factoring. Now we're going to fill in the spots. I'm going to take the cube root of 125, into the sixth, and the cube root of 125 is 5. So 5 into the cube root of into the sixth, divide 3 into 6, is into the second. And then I'm going to take the cube root of 1, which is 1. And then remember, to find what goes here, I have to square this, so that would be 5n squared. Sorry, it wouldn't be 5n squared. 25n squared. And then to find what goes in this spot, I'm going to square this. 1 squared is 1. And then to find that middle term, I'm going to multiply the first two terms. 5n squared times 1 is 5n squared. And that's my answer. I don't know why I keep moving that. Undo. So this is my answer to that one. Now let's do this next one. Hopefully you noticed that I had a common factor. So I took out 3. Or I'm going to take out 3. 1029 divided by 3 is 343. P to the third. 24 divided by 3 is 8. Then I did my signs, same, opposite, always plus. Bring that 3 down. Then I'm going to take the cube root of 343, p to the third, which will be 7p. Then I'm going to take the cube root of 8, which would be 2. Then to go in this first spot of the trinomial, 7p squared is 49p squared. And then the last spot of the trinomial is 2 squared, which is 4. And in the middle, I multiply 7p and 2. And that would be 14p. I was going to do 2 more examples, 5 and 6, but I don't have time as I'm limited to 15 minutes with YouTube, and I'm close to my 15-minute interval. I can do these if you need me to. Just let me know and I can do those for you. Hopefully from those examples that I've done, you've caught on. If not, message me and let me know and I'll do more for you.